All right, good evening. So yesterday we had completed terminal potential difference, EMF, and internal resistance. That was a very important portion. Now that completed one part of your lesson. The other part of your lesson is based upon your circuits. Series combination of circuits are there, parallel combination of circuits are there. There are combinations where you're not able to identify whether it's series or parallel. So there is a different method for solving those kinds of circuits. There are circuits which are connected with infinite resistors. Infinite numbers of resistors are present, and you are asked to calculate the equivalent resistance. So it has a different method of calculation. So different methods are there. Same is valid for capacitors. Same is valid for the resistors. So series and parallel combination we'll start with. See, before we start with the actual series and parallel combination, some questions do come from terminal potential difference, EMF, all these portions. Before that, let me just tell you what is meant by that. For example, cells are connected. External resistors are there. All these cells have their internal resistance. And these are connected to an external resistor. All of them, let's say, have EMF. Let's say this has EMF E1, this has EMF E2, this has EMF E3. This one has internal resistance R1, this one has internal resistance R2, this one has internal resistance R3, and so on. So EMFs are provided, R1 plus R2 plus R3. These are the internal resistance of the cells, and E1 plus E2 plus E3, all these are the EMFs of the cell, and they have been connected to an external resistor. Asta, it's audible to you?
Yes, ma'am.
All right, Asta. So, Asta, see, we are going to start a new topic, that is your series and parallel combination of resistors. Before that, a very small portion was left, so we are just discussing that, and we'll move forward to the series and parallel combination. Wherever you're not able to understand, stop me right there and ask me. All right?
Yes, ma'am.
Fine. So I was saying, yes, cells are connected. Now, equivalent EMF, if we have to calculate, EMF is basically electromotive force, which is whatever we have studied for potential. This is valid. It's basically the maximum value of potential difference, which is applied across the ends, or you can say it's the potential of the internal resistance of the cell. So when you are asked to write the equivalent EMF, you will simply add all these E1 plus E2 plus E3 up till so on, how many are provided to you. For example, let's say n number of cells are provided. So you will add E1 plus E2 plus E3 up till En. Similarly, equivalent resistance. Resistance, and what type of resistance? Internal resistance. So resistance are always, even if in whichever manner they are connected. See, remember, resistance can never come out to be negative. So resistance will be R1 plus R2 plus R3 up till so on, like this. Now, what was the formula? I mean, do you remember that formula of current that we have calculated? If EMF is given, external resistor is given, internal resistance is given. Yesterday we did a formula. If not, you do not remember it, then just turn the pages and see. Yesterday you must have written.
I is equal to EMF by internal
resistance plus external resistor. Perfect. That was I is equal to EMF. Basically using our Ohm's law. Ohm's law was what? This, using Ohm's law, V is equal to IR, we could write this. So we have just modified in terms of what was given. Now the formula will become E equivalent, means you will solve this and put in over here. External resistor plus equivalent internal resistance. Now regarding external resistor, we have a full-fledged topic today, series and parallel combination for today. How to get different values for external resistor. Right now, just remember, whatever you've studied yesterday, just add on to it that equivalent EMF will be sum of all the EMFs, internal resistance will be sum of all the internal resistances, like this. It will keep on adding. Now the question that I was mentioning. For example, this is a question given to us. What is the voltage of each cell? The voltage of this cell is 10 volt. Voltage of the second cell is 5 volt. Voltage of this cell is 15 volt. Now, internal resistance of this is one battery. So internal resistance of this battery is 1 ohm. Internal resistance of the second battery is 2 ohm, and the last one is also 2 ohm. You have to find out current through each cell. We use the same formula that we have just studied. So first, obviously, you have to write equivalent EMF. Equivalent EMF will be sum of all the EMFs that are present. So this becomes what? 15 plus 15, 30 volt. Equivalent internal resistance, 1 plus 2 plus 2. That becomes 5. This is 5 ohm. And what's the external resistor given? External resistor is given to you as 10 ohms. Now put in everything in the main formula. I is equal to E divided by E equivalent divided by capital R plus R equivalent. So formula becomes 15 divided by 5 plus 10, which is equal to 15, not 15, 30. Equivalent EMF came out to be 30 now. 30 divided by 15, which comes out to be 2 ampere. So current for the first part comes out to be 2 ampere. Then it says, what's the terminal potential difference across 10 volts? So what's the terminal potential difference across 10 volts? So EMF is given to you as 10 volts. Value of EMF right now for this cell, this becomes 10 volts. Internal resistance for this cell is what? It's 1 ohm. You have to find out what the terminal potential difference. So yesterday we studied an equation. This is the answer for the first part. Second part, remember this equation we had did, you must be remembering this, E minus IR. Remember this equation?
Yes, ma'am.
Yesterday we did it. So EMF of the cell is what? EMF of the cell is whatever cell has been mentioned to you. Right now, the question is asking you to calculate terminal potential difference of 10 volt. So EMF for you right now becomes 10 volt. Minus I, current you have calculated. R is 1 ohm. Internal resistance of the cell is 1 ohm. So this is 10 minus 2, which is 8 volts. So voltage for the first battery, that comes out to be 8 volt. Terminal potential difference. So this was a very small portion left. One more thing. For example, if I reverse one cell, this is known as reversing of cell. This is known as reversing of cell. Right now, just understand what is meant by reversing, because you have to identify whether a cell has been reversed or not. See over here. This is the positive terminal. This is the negative terminal. Positive terminal, negative terminal, positive terminal, negative terminal, and so on. This is the pattern that has been repeated. So it means cells are connected normal. None of the cells have been reversed. Now see here, plus minus, till here both of these are fine. This one is what? This is minus plus. Clear? So it means this has been reversed. Like this, it has been reversed. So what will the issue be in the R calculation? See, everything that you have studied remains the same except for one thing. In case of calculation of equivalent EMF, you have to calculate with a negative sign. Which of the cell is reversed? No, if you are able to identify. That's why I'm saying identification of the reversible cell is very important. If the second cell has been reversed, then I'll put a negative sign in front of the EMF. Internal resistance will no matter, it will get added up. Why the internal resistance it will get added up? Because internal resistance, this is it can never be negative. Resistance are what? Resistance is a scalar quantity. You do not have a direction. So if you subtract or take any convention or sign convention, it can happen that the resistance comes out to be negative. So that's why just add all the EMFs, add all the resistance. In case of EMF, whichever cell has been reversed, just add a negative sign to it. If more than, you just have to identify by yourself which cell according to you has been reversed. If two cells are reversed, then put two minus signs in front of them. If three cells are reversed, then put it. If you are able to observe that three cells are reversed and one is not reversed, it means three of them are in order. Whichever is odd, put a negative sign and subtract. Did you get the fact? Is it clear? Asta, are you able to understand all these things? Astha.
Yes, ma'am.
All right. Do one thing. Note down these things, then we'll begin the fresh topic so everyone will be able to understand. First, note down these. This was a small portion left from yesterday's class. Completed the writing part?
Yes, ma'am.
All right. So let's just start with the circuits now. See, first we have series combination of circuits. Before going into the details of series combination or parallel combination, you have to understand what is meant by branching, what is when is your current getting divided, or when is the potential or voltage getting divided. Branching means if a wire has been divided into two parts or a new wire has been added. For example, this is a continuous straight wire. It's a continuous straight wire. So current that will flow in this wire will be same. If I convert it into a form of L shape, still the amount of current that is the amount of charge or the current that is flowing will be the same. And current, we all have done it together. If I make it in the form of a circle or a closed loop, current that will be flowing in this loop, in this part, will be the same in this portion. Or if I say, even if I bend it somewhere or like this, if I bend it, current flowing through the same wire, this will be the same. So what happens in this case, even if I connect any device or resistors, for example, I have connected resistors. What is a resistor? You are aware of, Astha? Resistors, resistance.
Yes, ma'am.
All right. So, for example, I have connected a resistor. Still, the amount of current that is flowing in this will be the same. If I is flowing, it will be the same. But now talking about when the current divides. For example, a wire was like this. Then it got branched into two parts, and these are new two wires like this. So this is known as branching. What will happen? Current was flowing, current gets divided over here. Fine. Now, in case this was all about current, so current gets divided when there's a branching, and even if you connect a resistor, inductor, capacitor, any device, your current's value will not get changed. Now, when we connect this, when we talk about potential or voltage, whenever we are talking about potential or whenever we are talking about voltage, what happens is that if this branching occurs, so current is getting divided into two equal parts. But for a potential or for a voltage, basically voltage or potential, it won't get changed even if branching occurs. But if I had this plain wire and now I had connected it with a resistor, somehow I have connected it with a resistor. Now potential at this edge of the wire and potential at this edge of the wire, both of these are different because a capacitor, a resistor and all these block the your potential. So potential value gets changed, potential difference is different, so all these value get changed. So what is the conclusion? Again, I'm repeating. For a current, as you branch, current gets divided. Same goes for charge. As you branch the wire, branching means a new different wire has occurred in the series in the circuit, then the charge or the current gets divided. It does not affect the potential. Whereas if you connect a resistor, a capacitor or any device, that changes the potential around itself before and after the connection, but current does not get affected by that. These are two main important points. Now, how to identify series combination, how to identify parallel combination, these are only identified if you are aware of how the current is getting divided and you're aware of the fact how the potential is getting divided. Now, what happens is that current through each resistor, if it remains the same, let's say 5 resistors are connected. Let's make this. For example, let's say this is a resistor, this is another resistor, this is another resistor. Let's say n number of resistors are connected, R1, R2, Rn. Let's take Rn. N number of resistors are connected. And the potential here is something. So what happens? Current that will be flowing in this entire circuit, that will be the same. That will be I current only. But potential for each resistor, this will be different. Why? I have told you, in case of a device that has been connected, it changes the potential. So this will be the case or not? Do you agree till here, both of you?
Yes, ma'am.
Agreed? All right. So now see, if the current in any device, in any circuit you are solving, we'll solve many circuits. We'll see different cases. We'll be solving circuits. So when you will see if the current is remaining same everywhere, then automatically just declare the current, this combination as a series combination. But there should be a systematic formula. Even if you've identified, how would you solve it further? So for the solving part, the best way is, what will be the potential? If I say the net or equivalent potential, what will it be? I'll add all of them, V1 plus V2 plus V3 plus up till Vnth. Let's say n number of resistors are connected. N can be any value, it can be 1, so it will be a single resistor. If n is 4, then it is 4 resistors are connected, so any value is there. Using V is equal to IR. Asta, I think we didn't discuss V is equal to IR, no, in the last class. We didn't do it, no?
No, ma'am.
No, we didn't. See, it's very easy. Ohm's law says that. I think you must be aware also about it. I'm just repeating. Ohm's law says if the pressure and temperature, these two quantities remain the same, then whatever is the potential difference applied across the terminals of the wire, that is directly proportional to the current. So V is actually proportional to I. And when we remove the proportionality sign, we get a constant, which is known as resistance. And resistance opposes the flow or motion of charges, what we have been continuously studying. So if we apply Ohm's law over here, I mean, can you try for the first resistor, what will be the value of V1?
Ma'am, I plus I into R1.
I into R1, perfect. I into R1. Similarly, this will be I into R2 plus I into R3 up till I into Rn. And this is equal to what? This is equal to the total current in the circuit into total resistance of the circuit. See, I gets cancelled from everywhere. R equivalent comes out to be what? R equivalent is R1 plus R2 plus up till Rn. This means the formula for the series combination of resistors is very easy. Just keep on adding. Just add all the resistors that are given in the combination. So this is known as series combination. This is the formula for calculation of equivalent resistance. Now in the questions, not only this will be given, some more things will be asked. Like what's the current through each resistor? What's the potential through each resistor? So current through each resistor will be what? Will it be different or will it be the same?
Same.
Same, definitely. So even if the current, even if the question asks you people, no, what's the value of current through a particular resistor or a different resistor, if the total current in the whole circuit is, let's say 5 amperes, you don't even need to calculate. If it's 5 amperes for the whole circuit, then for each resistor, it will be 5 amperes only. So current through each resistor I1, I2 will be equal to I1. Now, voltage through each resistor, will it be same or different?
Different.
Different, exactly. So V is equal to IR, and Aman has already answered that what was the potential across a resistor. Similarly, this will be the same. V1 will be equal to IR1, V2 will be equal to IR2. Similarly, Vnth will be equal to I into Rn. Means whatever is the resistor given, like this. Some more things can be asked to you. What's the power dissipated across each resistors in all these? See, formula for power that you will use in series combination. We are doing it simultaneously. Otherwise, power is taught as a separate topic as well. But it's okay. We'll do it along only. So that the formula and when to use the formula, basically usage of formula gets clear to both of you. Power's formula that we'll be using in case of series combination is I square R. P is equal to I square R. This is the formula for it. So for the first resistor, it becomes I square R1. For second resistor, it becomes I square R2. For nth resistor, it becomes I square Rn. Like, yeah, so note down all these things at any step. If you face difficulty, ask me. Let me know whatever doubts you have. Start noting from it, then we'll do a numerical about this. Try the first part and second part at least, R equivalent and the total voltage, and submit it in the chat box.
Ma'am, what's the first one? Resistance?
It's 5 ohm. This is 5 ohm, this is 10 ohm, and
no,
the
ma'am,
battery is 10 volt.
in the question,
This
calculate.
is R equivalent. R
Oh, okay.
equivalent resistance. Yes, Sastha. First answer is correct. I mean, you must have also got the answer of the first part at least. Equivalent
Yes, ma'am, I did.
resistance. Yes, yes. Submit, submit. And we'll
Okay,
discuss.
I'm just solving all of them first and then submitting together.
Okay, then I think 2 minutes are enough for both of you to send the rest of the parts. Let's take 2 minutes and then we All right. So first answer, this is 15 ohm, correct. Second answer will be 10 volt, definitely. See, first answer you can easily see and calculate. These kinds of questions are very less in your exams. These are very simple formula based questions. The combinations that you will get, they will have no more number of resistors. Some will be in parallel, some will be in series. So there you have to identify that, we'll see later on. So it's simply 5 plus 10, 15 ohms. Total voltage is written in front of you, that is 10 volt. Third part says what? Third part says total current. So total current can be calculated using, I'm starting from the second part because first and second, both of you have written it correctly. Second part is V is equal to IR. So we have to find out what? Total current. So total current will be total voltage divided by total resistance. Total voltage is 10 volt, total resistance is 15. So this comes out to be 5 by 2 by 3. Correct. This comes out to be 2 by 3 amperes. So what was the answer Astha submitted? I is equal to 2 by 3 amperes. Correct. Voltage across each. See, voltage across each, we have to calculate it. For the voltage, I have told you that it is I divided by R1. So V1 becomes what? I is 2 by 3 into R. Or let's just write it in terms of 10 or 15. Or let's leave here. This is what? This is, first one is 5. So this is 2 by 15 volts. Second part is, for the same question, this is V is equal to 2 volts. V2. So this becomes I divided by R2. Now V2 is equal to I is 2 by 3. R is 10, no? So this becomes 2 divided by 30, which is 1 divided by 50. This is also right. So someone, I think, has submitted the answer. 10 by 3.
Ma'am, the formula is V1 is equal to IR1.
Oh, yes, yes, yes. I have written it. That's why the correct is I into R. Correct. V into R. Right. Because your Ohm's law says what? Ohm's law is V is equal to I. Yes, thank you, Asti. Right. That's why I was saying the answers are coming very different. V is equal to IR1, V is equal to IR2. So V1 will be 2 by 3 into 5. So yes, 10 by 3 volts, right answer, submitted by Asta. And V2 will be 2 by 3 into 10, that is 20 by 3 volts. Why I was able to wonder, why my answer was getting wrong, which you also have to cross check whenever you are performing calculations, is why when I was adding 10 by 3 and 20, when I am adding 10 by 3 and 20 by 3, I am getting what? If you add 10 by 3 and plus, exactly, that's 10 volt. And that was the original voltage. When I wrote previously, by mistake, what I had written in our, just a second, give me a second. When I had written earlier 1 by 15 or whatever, when I was adding it, I was not able to get 10 volts back. So that proved that I had committed some error while writing. So that's how you have to see it. Even for the current also. Current will be, when we'll see parallel combination, there you will be able to notice this because current will be different. Current across each will be the same. For the fourth part, what's the next part? Voltage across each is done. Okay, total current is done. This was the third part. No, total current is done. This was the fourth part. And fifth part is current across each. So see, current across each will be what? Current across each will be whatever you've studied. This is I1, which is equal to I2, which is equal to 2 by 3 amperes. So whoever has not noted, take a minute and note down, and we'll move on to parallel combination. Now the parallel combination. So contrary to the series combination, whatever we have studied, in series combination, current remains the same. In parallel combination, your voltage remains the same. So as soon as you'll see the voltages are same for certain resistors, you will come to the conclusion that so and so resistors are connected in parallel combination. And you will be using the formula for parallel combination. So this is a first resistor that is connected. It is connected to a second resistor. Let's say this is connected to a third resistor, to some nth resistor, and finally to the battery. So this is R1, this is R2, this is our nth resistor. Voltage in all these will remain the same. Whatever is the voltage of the cell, total voltage of the circuit, that will be for all the branches or all the wires. Now what happens to the current? In parallel combination, you are able to notice branching. At the junctions, you are able to see wires are getting divided. This junction, every junction. So what will happen? In this case, since it is getting divided, current will also be different. I1 will be the current that is flowing in this wire. I2 will be the current flowing in this wire. IN will be the current flowing in this wire. So this time, instead of adding all the voltages together, I'll add all the currents together. That will be I1 plus I2 plus up till IN. Now, if I is the current over here, just tell me, across this branch, what should be the value of current? I1. What should be the value of I1? I should write using Ohm's law.
V into R1.
V into R1. V divided by R1. Correct answer. See, V is equal to IR, no? From here, I will be what? V divided by R. Got it, Amin?
Yes, ma'am.
So this becomes what? This becomes V divided by R1 plus V divided by R2 up till V divided by RNF. And what are we getting? Total voltage divided by the total resistance that we have. This time, since the voltages are same, every voltage gets divided. So 1 by R equivalent will be what? 1 by R1 plus 1 by R2 plus up till 1 by Rn. So in case of parallel combination, what's the formula? All the resistors get reciprocally added. And do remember to reciprocate it because you are taking the reciprocal addition. In series combination, you had to add it all together. 1 plus 2, 1 plus 2 plus 3 plus 4 like this. Here you have to take 1 by 1 plus 1 by 2 plus 1 by 3 and in this manner. Now, again, certain things can be asked from here as well. If voltages are asked, voltages will be the same. If current is asked, so that will be V divided by R1, V divided by R2. So IN will be V divided by Rn. Like this, you have to write it. If power is asked, you will use the formula V square divided by R1. This will be P1. P2 will be V square divided by R2. So PNth will be V square divided by Rn. This is the formula you will use in case of parallel combination of resistors. Fine, the rest of the things remain the same. We'll do a question as well on this. First note down this, then try the question, one more question on this. So only Astha has submitted all the answers. I was seeing the answers of Astha. All of them are correct. What about you, Aman?
Now I'm just typing them right now.
So R equivalent will be what? 1 by R equivalent, this will be simply 1 by 5 plus 1 by 10. So first answer, it's 3 by 10. See, if I solve this, this becomes what? 10 plus 5 divided by 5 into 10. 1 by R equivalent is what? This is 15 divided by 50, right? So as you people have already solved this, see, what's the point? This is what? Okay, let's just reduce this. This becomes 3, this becomes 10. I mean, you have submitted your answer here. Is 3 by 10 R equivalent or is it 1 by R equivalent?
Oh, it's 1 by R equivalent.
Okay, got it. So R equivalent will be 10 divided by 3 ohms, like this. Fine. So total voltage will definitely be 10 volts. That is correct of both of you. Last part says what? Total current. So total current will be different, obviously. Total current we have to find out. If we know total resistance, we know total voltage, we can find out the total current. So third part says what? Second part is 10 volt. Third part says we have to find out total current. No. So current will be equal to what? Voltage. Voltage is 10. Equivalent resistance is 10 by 3. So that becomes 3 amperes. 100 by 3. Did you get it? Okay,
Yes, ma'am,
your
I got it now.
resistance was wrong. No, so that's
Yes,
why
ma'am.
everything.
Right.
All right, fine. So then what's the next part? Total current we have done. Voltage across each. That will definitely be 10 volts. So voltage across each. Fourth part, 10 volt everywhere because it's the voltage. All right,
Yes.
current through each. Let's see. Current through each, we'll use this formula. I1 will be equal to V divided by R1. So I1, this is equal to V is what? 10 volt. R1, 1 is 5, so this becomes 2 ampere. I2 will be equal to V divided by R2. So this becomes what? 10 divided by 10, which becomes 1 ampere. Now see, if you combine, you get 2 plus 1, which is 3 amperes. And 3 amperes was the initial current that we had started. So I think Astha's all answers are right now. 10 volt, I is equal to 3. Oh, perfect, Astha. All the answers are right. I mean, just a silly mistake of reciprocation. So that's why all the parts got just
Yes,
done.
ma'am.
All right. Just note it down. And just text me done when all of you have written it.